factors, and they're zeros. So the main important thing, I look at this and I say, hey, so we have x minus I. Anytime I see an I know that the conjugate is going to exist, right? So if x minus I square root of 3 is a 0, or is a factor, that means what else has to be a factor, man? Right. Now we can just multiply this. You could use FOIL and break it all out, box method. Or hopefully you guys just kind of see that, oh, it's just the difference of two squares, right? So we're going to have I squared and then times 3. So we would really get x squared. That becomes a negative 1, so it's plus 3. So that's going to be our factor. I squared is negative 1. Negative 1 is positive. And then square root of 3 times square root of 3 would just be 3. OK, so now what we can do is apply long division. Because we can't use synthetic division here because it's not a linear factor anymore. So we want to set up long division. So I say x squared plus 3. This big polynomial, x to the 4th plus x cubed plus 5x squared plus 3x plus 6. OK? And just remember, guys, with long division, you're always using this front term first. So x squared goes into x to the 4th, x squared times x, and then you got to make sure you multiply x squared times both terms of your divisor. So therefore, I get x to the 4th plus 3x squared. I don't have anything here, so I could use an x squared or a place value. Put parentheses, subtract the rows. Here goes to 0. This goes to x cubed. And then this goes to 2x squared. So x squared goes into x cubed plus 1 time, or x times. X times x squared is x cubed. X times 3 is going to be a positive 3x. Subtract your rows. You're left with a 2x squared. X squared goes into 2x squared plus 2 times. 2 times x squared is a 2x squared. Bring down this 6. 2 times 3 is going to be 6. Subtract your rows, and you get 0. Cool. So we confirmed it's a factor, a double factor, right? And now we have our other factor. So all we got to do is factor that last factor, and we're good to go, right? Yeah? That's all we got to do. We're like at the home stretch. So therefore, we know that here's a factor, here's a factor. I can find the zeros from there rather simply. All I got to do for my last factor is set it equal to 0 and solve, and I'm good to go. So let's just factor this real quickly, and we'll be done. What two numbers multiply to give you 2, add to give you 1? Ooh, shoot. It's non-factorable. Dang it. So just got to hop and jump over the quadratic formula. It's not too bad. Opposite of b. Hopefully you guys notice that you are going to be good at this. 4 times a times c all over 2 times 1. So x equals, let's see, that's going to be, 4 times that's going to be negative 7. So therefore, I can rewrite this as, let's do it over here, negative 1/2 plus or minus I square root of 7. Whoa, this is kind of cool. All of our zeros are imaginary. But how many of them do we have? Plus or minus, plus or minus. Yes, did I make a mistake? Yeah, I forgot the 2. Thank you. Good catch. But we have 4. And how many zeros are we supposed to have? 4, right? Now, so if I want to write in the zeros, I would just write in x plus or minus I squared root of 3. Oops, I'm sorry. Just write plus or minus I squared root of 3, as well as negative 1/2 plus or minus I squared root of 7 over 2. Right? Now, guys, is it possible to have a polynomial to the 4th power with no real zeros?